So nominal data are numbers that are produced by a scale that represents named categories. They have no inherent numerical value. So you could have yes or no, Democrat, Republican, breakfast, lunch, dinner, any one of these sorts of responses. Any number assigned to this type of data, nominal data, like 1 for yes and 2 for no, is just arbitrary because one being yes and two being no doesn't mean that no is twice as much as yes. It's just arbitrary. I mean, you could just as easily say yes as 145 and no as 557. Same with any of these. These numbers are assigned arbitrarily. So why would you actually want to assign them arbitrarily? Mainly it's for statistics reasons, and so when you have a statistical package and you're using nominal data, you still need to tell it this is a yes response and this is a no response. Rather than typing it out, you just put a 1 in or you put a 0 in to indicate each of those things. It's just to help you remember which one of these things, which one is a yes and which one is a no, sort of breaking it up that way. Now, examples of nominal data. So one of the examples I'm going to give you here, several of the examples are true examples. This is one of those true examples. Stanley Schachter in 1959 was actually interested in looking at affiliative tendencies, like how much you want to be with other people. And so what he ended up doing to be able to test this is he's divided people into those expecting to experience severe shock and those not expecting it. And so I think all of the participants in this study were female for some reason. And so what he did is he'd have all the women come into the lab, and some of the women were led to believe, half of the women were led to believe that they were going to expect a severe shock, and that the experiment was about measuring physiological reactions to that intense electrical shock. The other half of them were told the shocks would be very mild and they'd feel like a tickling sensation. So the only difference in what these people were actually told was they were expecting something severe, and in other words, just like it's just going to tickle you a little bit. And then after warning them about the upcoming shock, he said, okay, you're going to have to wait 10 minutes while the equipment's going to be set up. Then he asked these people whether they wanted to wait by themselves, wait with others, wait alone, or if they had no preference at all, whether they wait alone or with something else. Now, what he was actually interested in was their answer to this particular question. So here's an example from what we were talking about last week in terms of ethical implications. He's basically interested in their choice when they're expecting something severe, potentially painful, or if they're expecting something that shouldn't be bad at all. He wanted to see whether people are more likely to want to be with other people if they're expecting something that might be hard and unpleasant versus when it's not going to be unpleasant at all. Now, if he'd gone ahead and he had to lie, because if you said, oh, I'm going to ask you this question just to, and then make you a little bit scared just to see how you responded, but that wouldn't work. So he had to lie to them. So after they answered that question, they didn't have to do anything else. They didn't go and get a shock or anything else. He was just interested, dependent variable, in terms of this. Now, in terms of independent and dependent variables, this ask them to wait 10 minutes, their response to that question is their need for affiliation, and there's 3 levels of it. Actually, this would be their answer to the question is that, but this is varying. Do you want to sit with others? Do you want to wait alone? Or is there no preference at all? There's 3 different categories there. And then he's looking to see how many people answer each of those things. So this is one of the ways that you actually represent nominal data. And so you can see it in this graph right here, is that you have the number of people expressing the preference of wait alone, wait with others, or don't care. Then you also have people expecting severe shock and those expecting mild shock. So essentially in this data, all you're doing is how many people chose this when they expected severe shock, how many people chose this when they expected mild shock. And that's what we're looking at here. So those expecting severe shock, 3 of, let's see, not 29, 30, 31, 32, 3 out of 32 people chose to wait alone. 20 out of 32 people chose to wait with others, and then 9 of those people expecting severe shock didn't really care. And so when you're looking along a line like this is like what he's really interested in, the difference between this and those expecting mild shock. This should lead up to add up to 100%. So that's 63, 86, and then 86 plus 9. That's not quite 100%, is it? It's 95%. It should be about 100%. Maybe other people were like, just get me out of here. I'm not going to do this experiment. I don't know. All right. And then here you see those expecting mild shock. So once again, you've got 60%. This would be 93% plus the 7 would be 100% right here. So 60% of them did not care in this case, 18 of them, and then 10 out of that, the total numbers, that's 28, 29, 30 people in this condition, and that would be 33%, and then 2%. So the reason I'm going through this is here are the raw numbers of each people in each condition. Those choosing to wait alone, expecting a severe shock, waiting with others, expecting a severe shock, don't care, expecting a severe shock, versus wait alone, mild shock, wait with others, mild shock, don't care, wait with mild shock. And so the numbers, okay, that's fine, but this percentage, when you look at the percentages, that really tells you what's going on. So expecting a mild shock, they didn't really care who they waited with. When they were expecting a severe shock, it did matter to them what they were expecting.